This video is going to focus on methods used to convert units that involve rates, and then some problems that you might be asked to solve that involve converting of rates. And we're going to look at actually two different sort of strategies that you could use in order to convert your rates of change. The first problem, we're going to do a sort of traditional method. You might have heard this referred to as dimensional analysis. And the next one's going to be a little more thinking about just sort of converting individual quantities. All right, so in this first problem, we're asked to convert 52 miles per hour into meters per second. And before I even begin, I am going to be pretty frank with you. On a speed unit like this, you could probably find the direct conversion using a calculator on the internet, and that's fine. As I've said in earlier videos, that is 100% acceptable, but I'm still going to use this as the sort of example problem. So if I want to convert this, I would start and I'd say, okay, well, we have 52 miles, and that's per 1 hour. Now I'm going to set up a giant multiplication problem. And it's almost in a way like I sort of want to, when I use dimensional analysis, I'm thinking about, I want to cancel units. So like I want to get those miles into meters because I'm trying to get from miles to meters. So I basically need to know how many meters, and I'm going to use just M for meters, are there in 1 mile. And that's something I would either be given on a unit conversion table or I could look up. And I looked it up in advance, and there are 1,609.34 approximately meters in 1 mile. So that multiplication problem right there would convert this into meters per hour. Well, I don't want meters per hour. I want meters per second. So I also need to get rid of this hour down here and turn it into seconds. And so what I'd do there is I probably would start, because I know this one off the top of my head, and I'd say that 1 hour contains 60 minutes. And so now I would have meters per minute if I multiply this out, but I want meters per second. So I'd say, okay, well, 1 minute contains 60 seconds. And sort of the quick check that you did this right is you can sort of notice, well, the miles divided by miles, hours divided by hours, minutes divided by minutes, and I'm left with meters per second. And this is really just a giant multiplication problem. If I write this out without any of my units, I have 52 times the 1,609.34 meters in that 1 mile times 1/60th. That's the number of hours in a minute, times 1/60th, the number of minutes in 1 second. And if I multiply this straight across, I would end up with 2,446.17 meters traveled in 1 second. And that would be my final answer. So this is one strategy. It works really well for some people. If you look in the textbook and My Math Lab, they're going to show you this strategy for converting rates. So on the next one, I actually want to show you a slightly different strategy. I personally like this one better. And it's going back more to what we did in some of the earlier problems. So here we're taking 403 cubic feet per second, and we're turning it into cubic yards per minute. So if I think about that, I have 430 cubic feet in 1 second. Now, I'm going to sort of take this step by step. In the end, I want to end up with cubic yards per minute. So I'm going to start with this number on the top. I have 430 cubic feet. Well, I don't want cubic feet. I want to turn that number into cubic yards. So this is a straight up use my unit converter calculator to do my conversion from cubic feet to cubic yards. So I'm going to go visit that. And oops, I need to go back to my home here. and I have a volume measure, and I want cubic foot into cubic yards, and we had, what was that? That was 430. And so I'm told 430 cubic feet is about 15.925 cubic yards. Fifteen 0.925 cubic yards. Okay, I'm good with that. Now, I want to take that 1 second and turn that, and so this technically, we're still like, per second. But I don't want per second, I need per minute. So the next step would be, okay, let's take that second, and we want to turn those seconds into minutes. And so again, I could go back to my, unit converter calculator, go time. I'm going to turn seconds into minutes. And so I want 1 second is about 0.16666. And you're like, what is that? Well, it's the fraction 1/60th. So I'm going to actually put down the fraction. So we have 1/60th of a minute. And that's 15.925 cubic yards. And this really isn't in the unit rate format. We want it per 1 minute. And so we're going to take this piece right here, and we're going to throw that into an actual calculator. So let's go visit our calculator. So we're going to our Desmos app, and we have that 15 point, and I have already forgotten the number, 15.925. And we're going to divide that. I'm going to put some parentheses here. 1 divided by 1/60th. That's not a 60th. That was a decimal. And I would get 955.5. So 955.5. So this would be 955.5 cubic yards per minute. And so this way, I like it because you're really thinking about, okay, we're going from cubic feet into cubic yards. I'm going from seconds into minutes. And so it's sort of breaking it back into that two sort of separate quantities to reach that final answer. All right, so now let's look at some contextual problems that involve these conversions of rates. And we have sort of two different ones we're going to look at. The first one's actually a population density question. So all that population density means is it's the number of people living in a fixed area. So it's like, if this is my fixed area, how many people are living in that space? And so it will often be people per some area unit. Now, we're told here that we have 1.6 million people on the Manhattan Island living in about 57 square kilometers. Now, in America, we tend to do per square mile when we look at population density. And so we're being asked to take it as people per square mile. Well, in this case, we're given a measure not in miles, but in kilometers. So I'm going to treat this just like we treated our last unit conversion problem, in which we started with a conversion of that unit. So I want to take that 57 square kilometers, and I need to turn it into square miles. And this would be something I would just go and I'd put it in, I'm going to scoot that back a little bit, put it into my unit converter. And so, remember, that's going to be an area, and we want to go from square kilometers, into square miles, and we have 57. And so it's about 22.008 square miles. So I'm going to go over here, and that's about 22.008 square miles. And then we want people per square mile. So I'm going to take my people. Now, notice it's written like this, 1.6 million. So we need to actually turn that into a number that we can put in our calculator. And so 1 million would be 1 followed by 6 zeros. So that's 1 million. So 1.6 million would be 1, comma 6, but then actually 5 zeros. So that would be 1.6 million people divided by that 22.008 square miles. And I would get approximately 72,701.5 people per square mile living on Manhattan Island. That's a lot of people. So population density is a pretty typical one you might see. You often will have to convert population densities if you're comparing the United States to other countries, because obviously other countries use the metric system while we tend to use miles. Now, here's another one, and it's looking at just sort of breathing patterns. But it is going to be a sort of rate that we have to convert. So it says we breathe once every 10 seconds. So how many breaths do you take in 3 weeks? And I could think of this, okay, so you have 1 breath per 10 seconds. That's sort of our ratio, which means I could turn this into breaths per 1 second, and that would just be 0.1 breaths per second. And so the key here is going to be to turn my seconds into weeks. And if you sort of think about that, I can sort of, to help me sort of, you can use the dimensional analysis thinking to help you here. So you can say, okay, well, seconds, to minutes, that would get us breaths per minute. And then, minutes to hours would get us breaths per hour. And then hours to days would get us breaths per day. And then days to a week would get us breaths per week. And then we could use the 3 weeks. And that would go through, seconds would cancel, minutes would cancel, hours would cancel, days would cancel, breaths per week. That's one way to think about it. We can also think about it going through doing that sort of multiplicative relationship that we had talked about earlier. So that would be thinking, okay, it's 0.1 breaths for every second. There are 60 seconds in a minute. So if I times that by 60, now I have my breaths per minute. There are 60 minutes in an hour. So if I times that by 60 again, so right here we're going to just use B for breaths per minute. Timesing it by 60 again gets us breaths per hour, because there are 60 minutes in an hour. And now if I wanted per day, I would times by 24, because there are 24 hours in a day. So now we have breaths per day. And there are 7 days in a week. So if I then times that by 7, I would get my breaths per week. And so if I multiply, and so we can go through and we can multiply this all out. So let's go back to our calculator. So we're going to use sort of our Desmos calculator. I'm going to just clear out what I have there. So we had 0.1 breaths per second times 60 seconds in a minute times 60 minutes in an hour times 24 hours in a day times 7 days in a week. So that would be 60,480 breaths per week. So let's write that down. So we have 60,480 breaths per week. Well, that's not the answer we're looking for. We were asked for 3 weeks. So basically we need this to happen, breaths per 1 week. We want this to happen 3 times. So this is where we're sort of using our rate. So we have our 6,484 breaths per week over a 3-week period would get us a total of 181,440 breaths, that's a lot, in 3 weeks time. So hopefully these problems have given you some different strategies you could take when dealing with trying to change the units within our rates. Stay tuned for some more complex examples that involve rates and having to make some decisions based on them.